Number 5, let's pick it up here as part 2 of this video. Find the lateral area and surface area of the cylinder. Give your answer in terms of pi. So let's go ahead and write up our lateral area first. Okay, lateral area is circumference times height in this case, so that's 2 pi r h. Okay. Now they show me that this line is 6, which means we just want the radius. So my radius is 3 and my height is 11. We want our answer in terms of pi. So 3 times 11 is 33. 33 times 2 is 66. My lateral area is 66 pi. 66 pi. All right. Now with surface area, we're going to end up taking our lateral area and adding it onto our pi r squared. All right, let's see if I can pick this back up. All right, surface area. Surface area is going to take that lateral area that we just found, and it's going to add the two bases onto it. So rather than go ahead and rewriting it, although it would be 2 pi r h plus 2 pi r squared, we already know that that lateral 2 pi r h is 66 pi. What we need to find is 2 pi 3 squared. Well, 3 squared is 9, and 9 times 2 is 18. So I'm getting 66 pi plus 18 pi. And again, we just want our answer in terms of pi. So we can take 66 pi and 18 pi, and we're going to get 84 pi. And this should be in my lateral area is meters squared. My surface area is meters squared. So we want 66 pi for my lateral, 84 pi for my surface. Notice that C takes both those numbers and switches them around. So we don't want to get those two mixed up. We need to know the difference between lateral area and surface area. All right, number 6. Find the surface area of the cylinder. This time we're going to use 3.14 for pi. Okay, round our answer to the nearest tenth. Again, they give me the diameter. I need the radius, which half of 26 is 13. Surface area. Again, we're going to write up our formula. Surface area is 2 pi r h plus 2 pi r squared. The only thing that we really need here is radius and height. So surface area equals 2 pi 13 times 15 plus 2 pi 13 squared. Okay, I like to go ahead and keep everything in terms of pi until the very end whenever they want me to put in 3.14. That way we're not estimating as we go, we're just estimating at the end. So we've got 2 times 13 times 15. Well, 2 times 13 is 26, and 26 times 15 is 390 pi. Okay, 13 squared is 169. 169 times 2 is 338 pi. So we're getting 390 pi plus 338 pi, which is 728 pi. We're going to substitute in 3.14 for that. 728 times 3.14. It's going to give us a close estimate of 2,285 centimeters squared, which is what we see for our answer, which is A. Okay, that is number 6. Let's come down to number 7. Okay, volume. Volume is the area of the base polygon. So volume equals pi r squared times my height. Find the volume of the cylinder. We're using 3.14. Volume equals pi. My radius is 3 My height is 14.5. Okay, round our answer to the nearest tenth using 3.14. Let's grab our calculator here. Okay, 3.14 times 3 squared times 14.5. 409.77, but we want it to the nearest tenth. So our answer is going to be 409.8 meters cubed. 409.8 meters cubed. Let's see if there's a matching answer for that. And it is A. All right, so we'll get that right there to the nearest tenth. Again, you see how much easier it is whenever we write down our formulas and then substitute into the formula. So you need to know these formulas. All right, here we're going to come back to our parallelograms. Number 8, a road surrounds the perimeter of the park shown below. The park has 2 bike paths that bisect each other, okay, to form an X. What is the length of the road in miles? Well, because they're telling me that it is a quadrilateral where the diagonals bisect, then I know that this is a parallelogram, which means I know the opposite sides are congruent, because once it's a parallelogram, all 4 rules of a parallelogram apply. So if I'm trying to find the length around the road in miles, we're going to take 12 plus 12 plus 16 plus 16, or 24 plus 32, and we're going to get 56 miles. 56 miles around the park. Okay. Number 9. Number 9 comes back to our cylinder. Swimming pool is in the shape of a cylinder. Okay. You might see several of these types of things around people's yards. It's got a height of 7 feet. Okay, a radius of 18 feet. How many cubic feet of water can a swimming pool hold? Use 3.14. So volume is, okay, pi r squared times height or depth. We're using 3.14 for pi. We're using 18 for my radius and 7 feet for my height or depth. So 3.14 times 18 squared times 7 comes out to 7,121.52 feet cubed. Okay, that's a lot of water. Okay, and they did not say how far to take that. That's how far we're going to take it. Okay, 7,121.52 feet cubed. All right, number 10. In quadrilateral ABCD shown below, AB is parallel to DC, and angle D is congruent to angle B. Is ABCD a parallelogram? Okay, so here's where I'm going to go back kind of to an answer. It's kind of a longer answer to look at here. Notice that AC is shared. Okay, so that is a shared diagonal. The diagonal AC creates triangle ABC and triangle CDA. Since AB is parallel to CD, okay, the alternate interior angles. So we also know that this angle and this angle are congruent. We know that this angle and this angle are congruent. So we have 3 angles, okay? All right. So you have BAC is congruent to angle DCA. Are congruent. AC is congruent to itself by the reflexive property of congruence. That's what we see right here. Therefore, we know that these triangles are congruent, because essentially what we have is the angle, 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 side congruency postulate. Okay, and once I know that these two triangles are congruent, then I know that their corresponding parts are congruent, which means that AD is congruent to corresponding side BC. And more importantly than that, I know that DC is congruent to AB. And once I know that DC is both congruent and parallel to DC, then I know that this is a parallelogram. So since both pairs of opposite sides of ABCD are congruent, it is a parallelogram. So you could go from a different couple standpoints. You could show that both sets of opposite sides are congruent, or you could just show that DC is congruent to AB and parallel, and that would be enough. Okay. Okay, 11 and 12 should be our last couple of questions. Find the lateral area of the cylinder shown below in terms of pi. Okay, if I can find it here. Okay. Lateral area equals 2 pi r circumference times height. Lateral area is 2 pi 6 times 9. We want it in terms of pi, which is going to make life a little bit easier. So we want 6 times 9, which is 54. 54 times 2 is 108 pi feet squared. 108 pi feet squared. Okay. And last but not least, as we get the rest of this in here, number 12. Find the total surface area of a right cylinder in terms of pi if the height is 30 centimeters and the radius is 29. Surface area, again, surface area is 2 pi r times height. Surface area, and then we need the two bases, so 2 times pi r squared. So surface area, again, we're solving in terms of pi. So we have 2 pi, my radius is 29, my height is 30. Okay. All right, so we've got 29 times 30 times 2. Okay, well, 2 times 29 is going to be 58, and 58 times 30 is going to be 1,740 pi, so a pretty big number. And then we have 29 squared, which is 841, and 841 times 2 is 682 pi. And then we're going to add these up. 1740 pi plus 1682 pi is 3422 pi centimeters squared. That's our final answer. Okay, so you guys should have the packet sent. Be taking notes. Make sure to get the formulas down and get this stuff written down in a place where you can use it. And that should be all for now.